Hello, I'm Mr. McBrien. This is TIJ1O Cold Light LEDs. So, about 125 years ago, a really neat idea came up. The observation had been made that if you heat up a thin wire, a filament, to a high enough temperature, you can get light. And we know that if you run current through a resistor, you get heat. The two ideas were combined together to create an extremely useful device. Now, to understand how useful it was, you had to realize that prior to the electric light bulb, the most common way to produce light was an oil lantern. And this was messy, it polluted, and it had great risk of fire. The light bulb was so important an idea that in fact it became the symbol for a good idea. And for about 100 years, the light bulb was the method of choice for generating light. But there was a downside. So if you'd like, you can pause the movie for a second and see if you can figure out what the biggest downside was of the incandescent light bulb. And I'll give you a hint, it wasn't how fragile it was. So the downside to the incandescent light bulb was that 96% of the power that it used went into getting the filament hot enough to produce light. And in fact, the light bulb produces so much heat that a famous toy, the Easy Bake Oven, used the light bulb as its heat source to make cakes and cookies. Alright, so there's an introduction. Today we're not going to talk about the incandescent light bulb. Instead, we're going to talk a little bit of LED technology, and in particular we want to know about practical use of LEDs. Okay, light-emitting diodes. The first red LED was produced in 1962, and it had some wonderful, wonderful characteristics. It had low power consumption, high intensity, it was durable, unlike the incandescent, and they were really compelling because they were monochromatic. What does that mean? They were a single color instead of white light, like an incandescent. And by this nature, how durable they were, how good an intensity got from low power consumption, they were very useful initially as indicators and for various mobile functions in low power devices. And if we want to compare different light sources, the incandescent, we don't need to define the lumens units really. We can simply say the incandescent gave us 10 lumens per watt. The fluorescent light bulbs that are above our classroom and that are still in many commercial buildings were about 7 times more efficient than that. So for the same power, you got 7 times as much light. LEDs, on the other hand, modern LED lights can give you 10 times the efficiency of incandescents. And to give an idea of how important that is, despite the fact that fluorescent bulbs are extremely fragile and contain toxic materials such that we pretty much have to clear out our classroom if one of them broke, billions of those bulbs have been purchased. And they're still used in our school today. And the reason why is this 7 times the efficiency between that and incandescents. So this gives you an idea of how important LEDs are. So what is an LED? So a light-emitting diode, for once its name describes what it does. It's a diode that emits light. Diodes are semiconductors, and their main function when they're not giving off light is that they only allow electricity to flow one direction. So we can say that they have polarity. Now, when you go to look at your LED and understand what that means, you need to look at it and see that the shorter leg is what we call the cathode. You don't really need to know that term. What you need to know is the shorter leg needs to be connected up to the negative terminal of the battery. And of course, that means the longer leg, the anode, has to be connected up to the positive side. And you can, in addition to, so if there's some damage to your LED and you can't see which leg is longer, there's also a flat spot on the negative side. Maybe a tiny bit about how LEDs work. So LEDs, when they're connected properly, the current flows across the diode. Negative electrons move one way, and positive holes move the other. So this is sort of a little bit of a lesson about semiconductors very quickly. Now, the holes exist at a lower energy level than the free electrons do. And some of you may be familiar with the first law of thermodynamics. Energy can't be created or destroyed. What it means is when the free electron falls into the hole, it loses energy, and that energy has to go somewhere. And in this case, the energy is converted almost perfectly to a photon, to light. And the color of the light is determined by the distance of the fall from the conductive band down to the hole. Well, that gives us the color of the light, the energy level of the photon. Okay, you won't be tested on this, but I thought you might be interested in a little bit in how it works. Another cartoon of a diode, of a light-emitting diode. It has a transparent plastic case. It has the terminal pins, and the diode is actually inside that plastic case. There's a lot of different forms of LEDs. They are various colors, various sizes, and even various brightnesses. But we are most concerned with how to connect them up. So if we're using a low potential source, 1.5 to 2.5 volts, we need, well, regardless of the power source, we need about 10 to 20 milliamps. And so we need a resistor because the resistance of the diode itself is extremely low. We need a resistor to keep the current down. So at these potential levels, we would use a 470 ohm resistor. The important sort of figure to keep in mind, any current over about 40 milliamps, and your LED is liable to burn out very quickly. Okay, so to summarize then, LEDs are useful because they are a very efficient way to generate light. Instead of generating a whole lot of heat and a little bit of light, they generate lots and lots of light. They're polarized. We have to make sure to connect them the right way or they won't work. Positive connection needs to go to the longer pin. And they have very low resistance. If we connect them up to a potential source without a resistor, we'll burn them out. Okay, for your homework, what I'd like you to do is assume the resistance of the LED is very close to zero. Now we want a current of about 10 milliamps as we covered. So with a 9-volt battery, what resistance are you going to want? Thanks very much. Have a great day.